Today we start our introduction to quadratic functions. We do have a few terms that we need to discuss just as far as vocabulary. So we start with the parabola. A parabola is the U-shaped curve created by graphing a quadratic function. Notice that it is U-shaped, not V-shaped. That means at its lowest and highest point, it's going to have a rounded curve, not a sharp point. Okay, so it's a U-shaped. The axis of symmetry is the second term we need to know. This is the vertical line that divides the parabola into two symmetric halves. And the final term that we need is a vertex. This is the turning point of the parabola. It's where the parabola changes direction. If it is going negative, it will change at the vertex to a positive direction. If it was moving in a positive direction, it'll change to again going in a negative direction. Okay, so several main ideas to talk about here. We're going to start over on the left side of the page just to kind of fill in a few additional things that we need to know about parabolas and about quadratic functions. So first off, the standard form of a quadratic function is written as y equals ax squared plus bx plus c. A, b, and c here are usually a numeric value, and they just represent the coefficient in front of the x squared, the coefficient in front of the x, and the constant in the equation, the number that's on its own. Now, if we want to look for axis of symmetry, there is a formula for that as well. The axis of symmetry is x equals negative b divided by 2a. So using those same a, b, and c values, the formula is negative b divided by 2a. You want to find the axis of symmetry. You are going to substitute the a, b, and c values from the equation that's written in standard form into the formula and simplify it. Okay. Make sure that when you substitute the values that you put them in parentheses. Because of this negative in the formula, sometimes your b value is also negative, so you want to plug that in with parentheses just to make sure that you keep all of your negative signs straight and where they need to be. Okay. All right, the final piece of this down at the bottom, to find the vertex, you're going to substitute the x value from the axis of symmetry into the quadratic function and simplify to find the corresponding y value. So basically what we have here, if you look at this example here, this graph, we have a parabola. It's moving in a downward direction. It reaches its minimum point, a lowest point, and then it changes direction. So this point right here is where it's changing direction. That's our vertex point. But not only that, if I split this parabola straight down the line that goes straight through that vertex, that's my axis of symmetry. It's symmetric on the left side as well as on the right side of that vertical line. So that's why to find the vertex, all we need to do is have our axis of symmetry, and then we plug it into the equation up here to find what y is, because we know that it has to be on the axis of symmetry because that's where the vertex is going to be located. So we'll practice that in here in just a minute. A couple other notes. If you look over here, we have an example of y equals x squared plus 4x minus 6 and y equals negative x squared plus 2x plus 4. So on this, there is a small error. We'll fix that. There should only be one equal sign there. But if a is positive, the parabola opens upwards. Notice it's moving with its opening up at the top. If a is a negative number, Okay, notice here we had a positive 1 as a coefficient, and here we have a negative 1 as a coefficient. The parabola opens downward, meaning its opening is down at the bottom of the graph. So that means, in context, if the vertex is the lowest point on the graph, it is called a minimum. And if it's the highest point on the graph, it's called a maximum. And both times it's going to occur on the axis of symmetry. Okay, so let's just look through as an example. So we'll start by, we need to know what A, B, and C are. So if we look at our example here, it's in standard form. So my coefficient in front of x squared is 1. We know that anytime there's not a number there, it's understood to be 1. B is this number right here. That's a 4. And C is going to be a negative 6. And it's a negative 6 because the original formula or the original form is a positive here, a plus sign. So if it comes across as a minus sign here, we know that this value is going to be a negative. Okay. So now we're going to plug that into our axis of symmetry formula. So x is going to be equal to negative b, which is 4, divided by 2 times a, which is 1. And then we would just simplify that. So we have negative 4 divided by 2, which when we divide that, we get negative 2. So our axis of symmetry is at x equals negative 2. So if I go to my graph and I count over to the left 2 and I draw a straight vertical line right here, I'm just doing a dotted line so I can see it. Okay, if I do that, it runs right through my vertex point. Everything to the left, everything to the right is symmetric. Okay. Now, to find out what this point is right here, the lowest point on the graph, I need to find out what that y value is. Now, I could count it on here if I have it graphed, but mathematically, I can also find it by taking that x value and plugging it into the original equation. So the original equation, y equals x squared plus 4 times x minus 6. And notice every time I had an x, I just put in a set of parentheses, and I'm going to replace that with a negative 2. So I plug this straight into your calculator, or you can do the math here. Negative 2 times negative 2 is a 4. 4 times negative 2 is negative 8, and negative 6 gets brought down. When we simplify that, 4 minus 8 minus 6 gives me negative 10. So my vertex is a point on the graph, so it's going to be written as an ordered pair. X is negative 2, y is negative 10. And if I look here on my graph, negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 10. That's my point. That's my vertex point. So negative 2, negative 10 is the vertex, and x equals negative 2 is the axis of symmetry. Okay, so that's a positive or an example. Now, if we want to look at the negative a example, we have this over here. It has a maximum point. It also has an axis of symmetry there that runs through that. So we're going to find those mathematically first. So we know that A here is a negative 1, B is a 2, and C is 4. So we're going to plug that in. X is equal to negative B, which is 2, divided by 2 times, and then here we have a negative 1. So negative 2 divided by 2 times negative 1, which is negative 2, gives us a positive 1. So our axis of symmetry runs at x equals 1. So I'm going to count over on the x-axis 1, and I'm going to run a dashed vertical line right through that point. And notice that that is my graph to the left, graph to the right. Everything is symmetric. Okay. All right, so then I have y equals, and I'm going to take that original equation again, negative, and in parentheses, I'm going to replace my x in just a second, squared, plus 2 times x again, plus 4, okay? And now I'm going to replace those x values with 1, because that's the x value where my axis of symmetry runs. So when I simplify this, I square the 1, and I get 1, but this negative 1 out here still goes with that. It's still multiplied by that. So I end up with a negative 1 here. 2 times 1 is 2, and then I bring down that positive 4. And so I end up here with 5 when I simplify. So x is 1, y is 5, and I count up over here. 1, 1, 2, 3, 4, 5. So I end up with a point at 1, 5, and that's my vertex. And I end up with x equals 1 as my axis of symmetry. And those are the basics, terminology and just kind of the basics of the standard form and some of the things that we need to know about quadratic functions.